we'll see how we get into this material. So tonight I'm going to try to cover, I guess for us it's chapter 9. It's module 2, but chapter 9. And we're going to talk about classes, which is the main topic of the chapter. And then I'm sort of setting up some of the techniques and things that you're going to need to know when we get to like module 5 in a few weeks, and have the sort of like the class project. It's out there if you wanted to start looking at it, but I may tweak it some more on the requirements, and yeah, I'm not sure I'm 100% happy with the full details of it, so it may change, but you can get an idea of what we're going for in there and start playing around with it, thinking about it. But like over the next several lectures, I'm going to start introducing things that you're going to need to know when you go to do that project. So it may seem a little bit disjointed with what's in the physical chapter, but it's not a waste of time. And just my general style anyway is not to waste your time, but to try to introduce things that you'll probably need to know because they're commonplace in the industry, whether the book talks about them or not. Okay, so constructors, destructors, methods, properties. We talked about functions and different variations on functions, overloaded functions and things over the last couple of lectures. We talk about static and non-static. When you start talking about classes, you can vary the signature of the methods quite a bit. It's very powerful and very flexible, but if you don't understand what all those keywords mean, it can be a little bit confusing, so I'll go over that. And then the serialization, deserialization, there's a lot of different ways that you can do this, but I'm going to focus on JSON as our format. If you learn JSON, that's going to get you a lot of mileage out there in the real world, but even if you're going to be working with XML serialization, let's say, a lot of the concepts and the way you approach it are going to be the same as JSON, with minor changes that you can find out from, Compendium of All Knowledge, Google. So when we talk about a class, we talk about objects in the abstract. If I talk about a dog object or a cat object or an animal being more abstract than cat and dog, those are just abstract concepts. And in C# and other object-oriented languages, a class is how we codify that concept into something real in our source code. So in C# you'll typically have a separate source file, a .cs file, for each class, and generally they want you to make the name of the class and the name of the file name the same. So if I have a dog class, it's going to live in a file called dog.cs. The other thing to realize about C# is that everything in C# is an object. What that means is when you look at, like if you come up with a file and you put a class dog in your class, it doesn't look like it's got any base class, but there's an implied base class that all objects have, which is system.object. So even if you don't say it's derived from system.object, it actually is. Okay, let me see if I can just quickly show an example of a class. So I create a project and create a new file. It's pretty easy in C# to create a new class. You just go to the project that you're in and you right click on it and say add, and you can scroll on. You can say add new item and say I want to pick a class, or you can just come down here and just say, hey, I want to add a class. And it just asks you what you want the file name to be. So if I wanted to create a dog, I would say dog.cs, and when I say add, why didn't you do it? Oh, okay, it just didn't open it. That was weird. Usually it just creates it and opens it. But notice that it created a class for me already, a stub for it, and named it dog because that's the file name that I gave it. So there you go, simple, trivial class. And typically you wouldn't leave this way because by default classes are private, and which means that nobody outside of this assembly or outside of this is going to have access to it. So we wouldn't want to leave it as private. So I would want to add the modifier, the access modifier public. Now all of these access modifiers are in the book. They talk about them, so I don't know that I need to be encyclopedic with all of the different modifiers and what they mean, but we will talk about them a little bit. Just make sure you're referring to the book before you go to take your quiz or anything. So now public class dog is going to be accessible to anybody, and like I said, it's assumed that it's derived from system.object, but it kind of graded out. It's hard to see on the screen, I'm sure, but I think that means, yeah, you don't need to say that, I already know. But if I was going to derive it from some other class like animal, then that's where I would put that there. Now, it says animal's not found, yeah, obviously because I didn't create one, but if I wanted to inherit from animal, using our object-oriented principles, then I would put a colon after the name of the class and just specify what the base class is supposed to be. And that's the easiest version of it because it gets even more complicated than that. This language has been around for a long time, and they've shoehorned in a lot of features over the years. So yeah, it's going to get much more complex, but we'll just keep it simple for now. So as it says, public, protected, internal, private, or file. So that's the access modifiers that you can put on your class here. And each of them have different effects on your class, but we're calling them access modifiers because it means what are you going to be able to access out of this. If I say that this is a public class dog and I put a private int whatever, some private data member, since the class is public, does that mean that somebody that creates an instance of this class is going to automatically have access to this? No. When I say public, that means people that create an instance of dog have access to its public data members. So they would not have access to tail member. I need to provide access in some other way because I put the private on the data member. So the class is public, but the data member is private in this case. So that's just how it works. Like I said, the default is private. I should also say, when we talk about where the class can be referenced, we haven't talked about this at all, but there's a notion of an assembly, and I'll be using this term assembly as we go, but Console App 1 is the default name for this program that I created, but yours is probably going to be My Cool Project or some other meaningful name that you give to it based on what the assignment is. But I was being lazy and I just called this app Console App 1. If I build this project, hopefully it compiles. Yep, it compiled. If I go out here into the folder where that lives, and I drilled down into these folders a little bit where that got compiled, you'll see that it created consoleapp1.exe. I'm not exactly sure why it created a consoleapp1.dll, but let's focus on the exe for now. That is my assembly in this case. So if I wanted to run this program outside of the Visual Studio environment, here's the program that I could copy and paste someplace else or give to a buddy or whatever to distribute the program and let it be run someplace else. can double click on it, but it pops up so fast and goes away, it's hard to see it. So in C# and .NET in general, the exe that you're going to build is an assembly. So anybody within that assembly, which means all of these source files that I'm looking at, that I created as part of this project, you can access this public class dog from any of those source files. So I can come over here to my program.cs where my main function is, and I can say var d equals new dog. Right? I have access to it. That's what that public to this assembly means, or public anywhere in this assembly. But when we get later on, we're going to have other assemblies. Anytime you, like if we open up this dependencies node in our solution, and we start looking at some of the things that are in here, the Microsoft.NET Core app is a place where there's a whole bunch of namespaces, and it's not one-to-one, but many of these namespaces, the objects in those namespaces, system.object, system.math, all of the code for these items, they live somewhere in some assembly. That somebody at Microsoft created an assembly and put the code into a DLL that houses all the code for that assembly and distributed it to us as part of the Visual Studio or .NET library of objects. And so we add those as a dependency when we want to reference them in our project. So we can create our own assemblies that are not EXEs. If I right-click on the solution and I say add, right-click, add new item, and I say I want to add a something's wrong with the way they've got the templates installed on this instance of Visual Studio. I'm guessing that you're going to have the same problem on your machines there, since they should be configured the same as this. But I should be able to just say, I want to add a new project to this solution. There it is. Maybe I right-clicked on the wrong thing. So if I right-click on the solution, and I say add new project, there we go. I can all project types. So I want a class library. So I'll pick library. So here's just a simple class library. I'll call it my library. And let's say maybe I move my dog into that class. Delete the default class that I put in there. Okay, so now I have two assemblies in my solution. One is my console app, and one is the my library, and the my library has dog in it. Now, if I go back to program, and I say var d equals new dog, it's going to say, what the heck are you talking about? What's a dog? Can't be found. But it's nice. It says, are you missing a using directive or an assembly reference? Okay, so I could try. Let's see, if I go to dog, it's still console app 1. I moved this to a different project, so I probably need to change my namespace here to get it to build correctly. But I could try and program to say, using my library, but same problem. It's going to say, what the heck is my library? I don't know what that is. Because there's one simple little step that I have to do to let my console app 1 library or assembly see the contents of my library. And that is in dependencies, I need to say right click, add project reference, and click on my library. That tells the Visual Studio build system settings that when you build this, first go build my library so I have an assembly, and then include that assembly in the dependencies when I build console app 1. So by listing my library as a dependency of console app 1, when I say build, now Visual Studio has to build my library first. If I say build, rebuild solution, you'll see down here, first it does my library, then it does console app 1. Make sense? It's pretty simple, but if you've never done this before and somebody says, hey, go add a dependency to this assembly, and you're like, what the heck is an assembly? Then it may not be so clear. But now that I've got both of them built, and now that I've got the dependency there, when I come back over to program, all of my errors went away. I can say using my library, and I can say new dog. It works just fine. Okay, so now it gets interesting. Now dog lives in this other assembly. So if I go over here and I say internal class dog, and I build, it says failed. Dog is inaccessible due to its protection level. Because internal says the dog class can be used anywhere inside the My Library assembly. So it can't be used from console app 1. In the same way, if I said, protected or private, all those things, anything other than public, if I want it to be used outside the assembly, I need to say that this is a public class. Now when I build it, it works. And now that I've got two assemblies, when I come back over here, you'll see I have a console app 1 exe, which is my exe assembly, and I have a mylibrary.dll, which is my DLL assembly. And these are built as debug versions of these programs, so the PDB also you'll need to carry that around with you, because when Visual Studio tries to debug into these assemblies and step through them line by line, the PDB gives it all the symbol data that it needs to understand more details about the code than what the runtime needs to just run the program. Any questions about that? So in a nutshell, in a few minutes, that's what assemblies look like in C#, and the difference between your exe assembly and your DLL assembly, and how to add it. Okay, so that's prerequisite knowledge to context to make some of this presentation stuff make sense, hopefully. Yeah, so now public, protected, internal, all that stuff hopefully makes a little bit more sense what the context is and what we're talking about here. And like I said, I don't need to go encyclopedically through these. It's pretty intuitive based on the name of it, and the book goes through each of these things in more detail, so you can use that as a reference. Okay, a little bit more about objects. So, like I said, object is an abstract thing. Class is a concrete representation of what your idea is for this object. In the original days, like back before we had object-oriented programs, yes, I'm old enough to have had to write software in days when we didn't have object-oriented programs. We had languages like C, or BASIC, or Pascal, things like that. These were not object-oriented language, they were procedural languages. And in those days, you might have a structure that would define, let's say, a customer object, and it might list the methods and what fields would go into a customer object, okay? So a customer might have a customer ID, a phone number, name, address, all that kind of information. They might have other stuff, and you can define, hey, here's all the fields that go with a customer object. But then if you wanted to have code that acted on that object, you had to write that code someplace else. And it wasn't always easy to say, let's say I'm going to change the address field to street, city, state, zip. You're going to split those up. Sometimes it would be very difficult to track down all of the code in your program or system of programs that references that address data so that you caught them all. It was awkward. Well, when object-oriented languages came along, they brought all of the code, the data, and the behavior associated with that data together in a class so that you could codify the object all in one place. It was very nice, very convenient. You could do the same thing without declaring classes and defining classes and using them. It just made it more convenient. Yeah, so you'll hear a lot of terms for this. You might hear the fields inside a class referred to as a data contract for that class. Data, fields, properties, data members, all those things refer to variables that you defined inside a class. That's all it means. Like we talked about last time, functions. If you put a function inside a class, it becomes a method. It's just terminology. So, yeah. Okay, another brief trip around the long side of the barn. When we talk about static in programming terms or in object-oriented terms, I think we had a good conversation last time about the stack versus the heap, right? Memory stuff. This is going to be another kind of conversation like that. My classic example of this down there at the bottom, that last bullet point, when we use object-oriented programming languages to build web servers, there was this problem because what the web server would do is it would get an incoming HTTP request and it would create a request instance of a class, request class. It would create an instance of it, and it would hand the incoming request to it and say, okay, that's yours now, handle it. All right, well, when you create a new instance of a class, memory gets allocated. How much memory? Well, exactly enough memory as defined by the fields or variables that are defined inside that class. Make sense? If you have an int and a float and a string and a bunch of variables, if you add up the size of all of those variables inside that class, that's how much memory gets allocated when you create a new instance of that class. It's it's not rocket surgery, right? How much memory do we need? Enough memory to create one of these objects. Okay. But the side effect of that is, let's say, early web pages, they wanted this little counter displayed on the bottom of the page that said how many people have accessed this page. It's just a nifty little gadget that people like to put on their pages to brag about how many hits their page had. Okay, well, how do you implement that when every request that comes in allocates a new block of memory? Well, when you allocate a new block of memory, the counter gets initialized to 0. Okay, so you add 1 to 0 and you get 1. Okay, every single request that comes in starts with 0 and adds 1 to it, and you get 1. So the counter at the bottom of the page is always 1, even if it's hit 1,000 times. So it didn't work. So what we needed is something more. We needed something that would be persistent. So people would play around with, okay, I'm going to have a file on my web server called clicks or hits or something like that, .text. So the incoming request would come in, the code, would create a new instance of this class, and then the constructor or somewhere in initialization, it would go off and it would read that file, pull in what the last counter was, add one to it, save it, and then that would be the counter. Problem with that is, you're getting thousands of hits, thousands of requests coming in per hour to this web server, and often, in a multi-threaded environment, you'd have two people that would read the file. They would both increment it from 27 to 28. Request 1 would save 28, and request 2 would save 28 right on top of it. So now, okay, great, we see the counter going up, but anytime there's two requests coming in at the same time, we miss them. We're dropping clicks. We're not getting the true count. Okay, so reading it from a file is persistent. It's just not re-entrant. It's not thread safe to do it that way, okay? So what they did was they came up with this idea of static. So I create this request object, and I have my click counts variable inside that object, and I just mark it as static. And what that means is, instead of allocating and initializing that memory when the class is created, when a new instance of the request object is created, we create one of them for the executable, or in our case, the assembly. So the assembly for that class would only get one piece of memory for that variable. So you split the object in two. So now we say, how much memory do we allocate when I create a new request object? Now it's not so simple as just adding up all of the variables in the object. You have to add up all the non-static variables in the object, because the static ones were allocated and initialized when the assembly was loaded, when the web server started, in other words. Okay? That's now when the counter gets allocated the memory and set to 0. Now, each new request that comes in, the compiler knows, oh, the static thing is over there, and the rest of the non-static variables are right here in this piece of memory. Now, when you have the two requests or 100 requests coming in at the same time, all of them being processed simultaneously, each one of them is accessing the same 4 bytes of memory for that counter. So when each one of them adds one to it, they all get counted. So that's an example of where you would need a static data member as part of a class to provide that functionality. Make sense? So anytime you want one of them for the whole assembly, for all instances of that object for the whole assembly, you would mark that variable as static.
Can you use a different example for it?
That's the best classic one.
Okay.
I can come up with another one, but it's going to be just as vague and easy as that.
That's the best. I'm going to read over it again.
Yeah, but it's not that common. So it confuses a lot of developers. I remember there's been several teams that I've been on where the developers have some kind of an attraction to global variables, we used to call them, but static, these are essentially global variables that just syntactically live inside a class. But they're not great. There's cases like this where you need to use them, and that's how you do that, but most of the time you kind of want to avoid them and try to come up with a way to do it within the instance of a regular variable. Now that's just for the variables. Now, when we talk about a static method,
Yeah, that was the one, I saw you using it, and like, I haven't really used static too much when it comes to like putting them in my programs and whatnot. I didn't really understand it too much when it comes to the static, like
Yes.
methods and whatnot.
yeah, there is a difference between,
Okay.
all of the stuff that I was talking about, that just applies to the static variables.
Okay.
When I mark a method as static, you know how I was kind of saying we take the object and the code that, the behaviors that act upon that object, and we bring them all together. When you think about code, let's say that I've got, let's say I've got two account objects, and I want to add them together. What the heck does adding two objects together mean, right? We'll talk about that actually a little bit later, but let's say that I could define what it means to add two objects together. Well, there's two ways that I can do this. One of them is kind of an inside-out way, and one of them is an outside, external way. One way would be this account object. I could say I want a method inside this object where if I give you another instance of that object, you add it to this object, right? So you would create an add method, and you would pass it one instance of an object. So that's the one that you're going to add, and you're going to add it to this instance. Okay? That's kind of the inside out or outside in, however you want to see it, way. The other way is you can create a static method. And static methods, they're roughly associated to this object, to this class. You know, we put them in the class because they're roughly associated logically with the object. But a static method can't actually access the information in this instance. You can't access the variables. So remember when I was talking about the static variables and the non-static variables? You can't access the non-static variables because it's a static method. It's not available to you. Everything that you're going to operate on has to be passed to you, just like it's a regular function.
Okay.
So if I was going to do an add method, a static add method for two account objects, I would have to pass account object 1 and account object 2. I would do whatever operation I was going to do, and then I would return the resulting account object. And that would be a static method, because we're sticking in the class because, well, it's dealing with its behavior associated with an account object, but it really has nothing to do with it. It's not even allowed to access this data. So that's static. And like I said, this is all kind of, it's hard to figure out why would I ever use this and what's he talking
I
about.
was gonna ask, like, when are they like static methods mostly useful?
Yeah. So static methods are often used when you prefer to use the function in that way. Like I said, when you would prefer your code look like the external way as opposed to the inside-out way, which kind of gets to be a little mind-bending.
So you kind of have free roam with the static method if you want to? Okay.
Yeah. But like I said, I'll show you a couple of examples of that when we get into it. Okay, so all that's kind of preamble again to getting into some of this stuff. Going back to the notion of an object being an abstract concept, we can talk about, data architects or object-oriented programming language architects. We'll talk about composition versus, let's say, inheritance. And composition means that an object is composed of other objects. So a dog object has a tail object. All that means is there's something called a tail, like class tail, and dog is going to have a variable that is an instance of a tail. So the dog object has a tail object. It's composed of a tail object. It might have paw objects or, fur object, things like that. That's what the dog is composed of. It has those things. So it has that relationship. And that's compared with the is a relationship, which is when we say, well, a dog is a canine, or a dog is an animal. That means it's derived from, it inherits from the canine or the animal class. Animal maybe makes sense because what else would be defined or derived from the canine? Well, you might have a dog class and a cat class that are both derived from an animal class. I guess you could have a wolf class that's derived from a canine class. So maybe it does make sense, but... And then, like I said, remember, when we're talking about is relationships, every class in C# is a system.object. They're all derived from system.object. It's not composition, then, it's inheritance. I just throw that out there to make this make a little bit more sense, hopefully. So when you hear the book talk about composition, that's what all it's talking about, is when you define a class and you put variables, data members inside the class, now you've composed that object of those variables, of those data members. So it has a relationship. Okay, moving on. I like talking about properties inside classes because they illustrate so many of the things. They illustrate constructors, they illustrate all this stuff. So, I'm this old guy. I had to do it the hard way for so long. So when I see the new way that we can do properties in Java and C# and all these other languages, it's like the coolest thing since sliced bread. You can do so much with so few lines of code, but I still like going back, not to just talk about how old I am, but underneath the covers, the new, slick, streamlined way of doing things is doing the exact same thing. So if I show you the old way that we used to do it, it maybe provides you the context for understanding how powerful that one line of code is now. So let's talk about the old guy way. So in the old days, I would define a private variable, a private integer, and I would give it a name. It's like, well, why are we putting a private variable inside this class? Nobody can access it. And I would also give it a name like m_id, and that way, since I'm using this method, it tells me everywhere in my code, whenever I see m_id equals 0, oh, I know m_, that means it's a class member of this class. It's one of those variables that I defined inside this class. It's just a syntax helper, just a style helper to communicate to myself what it was that this is defined as. It's kind of gone by the wayside. People don't like that notation anymore, and the new way of doing it kind of makes it irrelevant. You'd never see this anymore because you don't have to define it yourself. And we'll see that next. But okay, so I've got this variable inside the class. So when I create a new customer object, I know I'm going to have 4 bytes allocated for this instance that this variable is going to be stored there. Okay? This .m_id is going to be how you access that variable. As you can see down here below, that's how you access it. Okay, in my constructor, so when we'll talk about constructors a little bit too, but I know I'm throwing a lot of this at you at once kind of thing, but bear with me. So this is my constructor for the customer object, and in that constructor, I need to just make sure that I initialize this variable to 0 to start with. So it's predictable. I know what value it has to start with. Okay, so I've got the variable, I've initialized it, and now I want to set it to a value or get the value of that back. That's when I have a public property, and going back even further than this, which I didn't see any need to illustrate that, you wouldn't even have this nice get and set syntax. You just have 2 functions inside your class, 2 methods. One would be get ID, and the other one would be set ID, and that would be the name of the function. And in that function, you would say, for the get one, you would say return m_id, and for the set one, you'd be passed an integer, and you'd say this .m_id equals whatever you passed in. So you'd have a variable and two functions for every property. Then in the middle times, in the meantime, we got this syntax, which, the get and the set keywords were invented, and they made the syntax look really slick. Here's your getter, and here's your setter. It becomes, a little bit more elegant to create your code. Fine, but it does the same thing. The getter returns this, the setter sets it to this. And over here on the left is how you would call that. When you're going to use that customer object, you'd say customer equals new customer. Since it's just been created, the constructor has been called. We know the customer ID is set to 0 because we see that over here. We're talking about kind of the life cycle of this object. I just created it, so all of the variables are going to be set to their initial values per the constructor. So I know customer ID is 0. So then I said customer dot, the name of the property, which here is customer ID, equals, and I give it a value. In C#, when you use this syntax, it's pretty slick. I don't have to say customer dot set ID, right? I just say customer ID equals. It's much more slick. Looks much more natural. And this value gets passed in as value. One thing I find awkward about the way C# did this is, where did I declare value in this code over here inside this property? They just made it up. Normally you'd have a, parenthesis or a parenthesis on the set, and you'd say int value. You would declare it, but there's no declaring it. You just have to know that in order to access the value that was passed in, you use the keyword value inside your setter. I just find that a little awkward language-wise.
Is this still like that where you can put like certain stuff like that, like value, you can just put it out there rather than just like,
Yeah.
Okay, okay.
Yeah, this still works, it's just the old way of doing it.
Okay.
Yeah. Yeah. So, it works, it's not too bad, it's clear to everybody what's going on here, but the new way is so much better. Yeah, and this class is public, the constructor is obviously public, the variable is private, and the property is public. Okay, so the new way we do properties is much simpler. It's all this one line. And I don't even need to put anything in my constructor. The constructor's empty here, see? This is what we call an auto-implemented property. Public int customer ID. I don't have to name or declare the backing variable. It's implied that there's now an int behind this. I say, yes, I want a getter, and yes, I want a setter, and it automatically assumes that you want to do what that previous example did. And the equals 0 out here at the end says that's what I want you to initialize it when after the constructor gets called. So this equals 0 still is something that gets done in conjunction with calling the constructor. I just didn't have to associate it with the constructor. Some people, it makes more sense to associate it with where the code for the property is. Okay, I can understand the argument. But yeah, this is so much easier. And you do the exact same thing as here. And when you're using it, you still say customer equals new customer, customer.customer ID equals 1001. That's the same. It's just the implementation of it is so much simpler. It just goes down to this one line. So every property that you're going to implement in your class, you just do it like this and you're done. But keep in mind that behind the scenes, same thing happens at construction time, the same thing happens when you do the getter and the setter. It's all in there. Like if you built the assembly and you looked at the underneath the covers at the intermediate language that got generated, it would still do all those operations. Like you could argue that the size of the compiled code is going to be exactly the same because they're doing the same thing. They're providing the same feature.
With that M_ID, is it just given like some, it's not really named like that?
It might have some kind of an internal $X27.4 name, I don't know. I'm thinking they probably in the name table, the symbol table, they just use customer ID to represent the memory allocated to it. As opposed to, you could say that's more efficient than having a second symbol called M_ID. They simplified that too. Yeah, so I like this. I think that's a positive step. Definitely cleans up your code. Okay, a little bit more about the constructor. There's a few things that you need to kind of know and remember about constructors. The simplest classic way of calling a constructor is just customer, the name of the object, name of the variable equals new, name of the object. Nothing in the parentheses. That's what we call calling the default constructor. In my class that I was showing you earlier, I had a default constructor defined. So there's three scenarios here. One is, let me just go back and look at this. See, this has a constructor that takes no parameters. So we're not employing a default constructor in this case. There isn't one. It's not doing anything. So if I deleted these 3 lines of code, I would still have a constructor. I would just be using the default constructor. And the default constructor does exactly this. Nothing. But since I provided one, it'll call this one instead of the default constructor. It's kind of a subtle difference, but terminology-wise, you have to realize that. Because, in the previous one, this is also a constructor that has no parameters, but it actually does something. It has code in it. So, it's the same thing. I provided a constructor with no parameters, and so when I create a new instance of this class, it's going to call my constructor. It's not a default constructor. The only time I would have a default constructor is if I did not supply one of my own. And just like regular methods, I could put parameters in here. I could pass the value that I wanted the ID to have, I could wire that out if I wanted to. I just haven't in this example. So the second call, new customer, and I pass it a value. So now I have to define a constructor that takes a parameter. And, it has to match the signature of the data that you're passing to it in your call. Similar to other methods, and pretty much everything about a method that we learned last time applies to constructors, except for the return type. It looks like a function, right? Looks like a function.
Yeah, that's what I was thinking.
Except that there's no return type. That's always how you know it's either a constructor or a destructor, because there's no return type. Because anytime it's going to get called, it's called in this context of calling new. You're going to create a new customer. Well, it's already defined what that's going to return. It's going to return an instance of the object. So it would just be redundant to say public customer, because the return type of the constructor is the object. Be redundant, unnecessary, and you can't change it anyway. I can't say public int customer, because it wouldn't make any sense to create an instance and initialize it and then return an int. What? It just doesn't make sense. So this is just uniquely how you define a constructor. Okay, so that's the second one. And so all I'm trying to make the point up here is anything that you can do with a regular method other than a return type, you can do with a constructor. You can provide default parameters, all of that stuff. And there's also a new modern version of this, because even providing the customer, the return type or the data type of this variable is redundant because we know what it's going to be. We're creating a new customer object, so obviously the data type is going to be customer. So this just kind of seems redundant to people. So they added this var keyword so that it's like, yeah, I don't want to specify the name here. It looks ugly. Just say customer cust equals new customer. So I'm just going to say var cust equals new customer. This does the exact same thing as this up here. The compiler still says, yeah, cust is of type customer. It's just a newer syntax.
Is that one default or?
It's just inferring the type.
Okay.
You said new customer?
Yeah.
So I'm going to assume that you mean customer is going to be of type customer.
Oh, okay.
That's all it is. It's just syntactic glue. But this is probably what you'll see most of the time. Just realize it's doing the same thing as this up here. It's just syntax. Both of them work. It's just people seem to prefer the new way of doing it. Yeah, another thing about constructors is objects can contain objects. So when you call the has a relationship again, it's composed of, a dog is composed of a tail. It's composed of paws. So if you create a new dog, the dog constructor is going to get called, but also the tail constructor and each of the paw constructors are also going to get called when you create that new dog object. The compiler wires that all up. It knows what the object is composed of, and it calls all those constructors in the right order. The little caveat here, the book goes into this too in some detail, so I mention it. When you're talking about an int or a float, those are instance type. Remember we talked about the by ref and the by value last time? If you're passing an int, there is no by reference when you're just passing an int. You're just passing a copy of it. It's a value type. It's not a reference type. And so you don't have a constructor for an int. Those data types don't have constructors. We call them intrinsic types or built-in types or instance types. They don't need constructors, they don't have constructors. They're just simple, they're not objects. And like I said, there's more examples in the book. Okay, so class customer, here's an example of a constructor that has multiple parameters. And this would not be unusual where you'd have a number of properties defined. And as you can see, this object is composed of an integer and an order object. And we have a property that returns an order object. But that order object is made up of a product name and a price. So you can do some pretty interesting and sophisticated things when you start using composition to build objects of other more complex objects. It gets pretty fun. But the rules don't change. You just create a constructor, you can pass in the values that you need in order to initialize that stuff, and compiler wires it all up. But so this is a much more complex object than what we created in the simple examples we started out with, but I'm still able to fit it all on one page, right? Imagine doing what I did here the old way. How many lines of code that would have taken? A lot more anyway. And then here's how I would instantiate that. var, again, variable name customer equals new customer, and then I just pass in the values that I want to use for those properties. Pretty elegant, huh? Yeah. I like it. We'll keep it. Okay, a little bit more terminology. So constructor, the definition of that is a method that instantiates an object. This whole instantiates, that's terminology that we use when we're talking about object-oriented languages. just means nothing more than creating a new one of those objects. Default constructor, the one that gets used when there's no parameters and you didn't supply one with no parameters yourself. We call that overloading, remember? Last time we talked about having multiple methods with the same name, but with different parameter lists. Those would be, we would all, if they share a name, they're all overloaded methods with different signatures, is the way we would say that. And just like that, we can have multiple overloaded constructors because everything that applies to a method applies to a constructor except for the return type. We just don't want any ambiguity. The compiler needs to know the way you're calling your code, which one of the constructors you intended to get called. So obviously, I guess it goes without saying, you can't have multiple constructors that don't take any parameters because they obviously have the same signature, and so the compiler wouldn't know which one to call. So it's going to complain when you try to build your code. Okay, another term, the default value of an object. If you see that on a quiz or something, what is the default value of an object? It's the value of the object and its data members that it's composed of hold when it's initialized using the default constructor. You know, if the default constructor was used, the value of the object is the default value. Yeah, and this is pretty powerful too. Constructors can call other overloaded constructors. You see that quite a bit too for complex objects that are composed of other things. Let's see, an example of that would be if we have a, let's say first name and last name, right? Let's say that your class has let's say it's a customer and you have a first name and a last name. One of the clever things that you can do when you define a class is, wait, inside the class, do I have two variables, one for first name and one for last name? Or do I have one that is the name? Because you could do it either way. If you have one variable that has the full name, when you say, I want the first name property, you could parse that name for the space and just return the first part of it, right? Or when if you have two different variables and you ask for the full name property, you can just concatenate them together and return the result. So it's pretty clever to be able to define your object where the people consuming your object don't know the internal implementation. And we call that implementation hiding, and it's very powerful, not just to be clever, but later on, you may want to change the implementation. And if you've exposed all your raw variables, well, now if you go change it, you're going to break people's code and it's going to compile over in the other building, you know? And that can be awkward. Then you got to go through change control meetings with them and paperwork and wait till they change their code, and then everybody's got to build and check in together, and it's just very awkward. If you use implementation hiding, it's doing it the proper way. People aren't dependent on how you implemented your code, and you're free to change it when and as you need to. So, pretty cool. But my point was, overloaded constructors, you could provide two constructors, one that takes first name and last name, and one that takes full name. Right? That way the people using your object can use it either way that they want to. They can create an instance and just pass the full name. They can create an instance and pass first name, comma, last name. Either way, your object supports both. So that's an example of why you might want to use overloaded constructors. But the thing about constructors can call other constructors, you might have the full name constructor parse out the two values and call the other constructor and pass first name and last name. It's a simple, trivial example, but it's an example of how, well, I already wrote the code to set the first name and the last name property. Why copy and paste the code? Why not just have the other constructor call that one, right? And that's very powerful, and it's, again, the appropriate way to think about it. You don't want to copy and paste your code in all these other methods, because then if one has a bug, you have to find all the places you copied and pasted it to and fix all those too. So, a lot of cool stuff. You know, if you just remember, oh yeah, that's really cool. If you get out there and you're doing the job and you're reading other people's code, you're going to see all these techniques, because this has all been refined and, oh no, this is a better way of doing it. Let's just all agree we're going to do it this way instead. It's not correct or incorrect, it's just, oh, this is a better, more elegant way of doing it. Yeah, overloaded operators, I already talked about that. Oh, overloaded operators. Now this one is pretty freaky too. Like I said before, what does it mean if you have if you have an account class and you want to add two accounts together? What does that mean? Does it mean you'll expect that the customer name or the person's name is the same, but like if you have your merging accounts, maybe you're adding them together, and so whatever the balance is, you add the balance together, and the new object has a sum.
That's what I would think, yeah.
And that's just an example off the top of my head, but you can say, well, conceptually, what that means is we're using arithmetic and we're adding those two account objects together. So whereas in an algebra class you never learn how to add two accounts together, you can define by overloading the operator plus for that object. It's really cool.
So like depending on if it's a string versus like an integer, yeah.
Yeah. So here's some examples. I don't know if you can read it very well here. But I've got a couple of examples, or like it says, what does it mean for you to ask whether a customer is true or false? Can a customer be true or false? I don't know what that means, but you can definitely define what an instance of the customer class, what it means for that to be true or false by overloading the true and false operator on that object. So anytime you ask if customer, you can define what true and false means there. So here's how you would define the class, no big deal, just a constructor, just a property, customer ID, an order. This is similar to the previous example, the customer object. So now I've got public static bool operator true. And yeah, that's just how you have to define it. To overload the true operator for the customer type. So in essence, we're passing an instance of a customer object, and we're asking, can you evaluate whether that's true? And what we're going to define that to mean is, if the customer ID is not equal to 0, then the customer is true. If the customer ID is equal to 0, it's false. Okay, so hold that thought. Let's look at how we call that. Well, I don't have an example. Oh, no, I do. So I create this new customer, and I instantiate it with a customer ID of 1001. So customer equals new customer. The customer constructor gets called. I pass it 1001. It sets customer ID, the variable inside here, the data member, to 1001. And returns. Now I have an instance of a customer object whose customer ID is 1001. So now I can say, write to the console, if customer is true, return the word true, else false. Now, the way I coded this, I just happen to know that we're just using the true operator. We're not actually using the false operator in this expression. But you get the idea, right? It's saying if customer is true, print true, else print false. So that's how you would use that. Now, does that make sense? I don't know. Maybe it does for your application. But if you wanted to use that syntax, that's how you implement it. You overload the operator. Okay? Why do we call that operator overloading? Because we have multiple functions called true with different signatures. This function true happens to take as a parameter a customer object. There's other, let's say there's an account, one that takes an account object and one that takes a dog object, but this one happens to take a customer object. So we're overloading the definition of the true function to take a customer. That's why they use that terminology. Okay, the next one is operator plus. And notice, I'm not adding two customers together, I'm adding an order to a customer. So I have defined what it means to add an order to a customer to mean set the last purchase by that customer to whatever that order was, and then return the customer. So this one does have a return, so do these, because they're operators, they're not constructors, right? So that allows me, it enables the compiler to understand what this means, to say customer, this instance of the customer I created, plus equals new order. And that's how, in essence, I set the last purchase by that customer to this order. The last order by this customer is now an apple costing $4.75. Pretty cool, huh? I love overloading operators when it makes sense. I think that's really elegant. And when I realized that we could overload operators, the first time I saw that, I thought, that is just cool. Okay, well, we have constructors, we also have destructors. And you don't often see destructors in C# for, simple programming. Obviously, you see them when you need them, but you don't usually need them because most of the data that we put into the object is also easily destructible. If I put a string, or I put, if I put an order inside a customer, or I put a tail inside a dog, those are just regular old simple, we call them plain old C# objects. I don't need a destructor because when the variable goes out of scope, or the garbage collector realizes that that object is no longer being referenced by somebody, or any of the myriad of reasons why the object is going to get reclaimed, .NET already knows how to reallocate all of that memory. We don't need a destructor in those cases. So this is kind of a made-up example of a destructor. This is not real. Where a destructor does make sense is, let's say we had an application that was a messaging application. You wrote a chat application. So you're running on your computer and he's running on his computer, and the two connect to each other somehow, and they can send messages back and forth to that program. Your program on your machine can send a message over there, and his displays it, he can type a reply, he sends it back, and you receive it, and you see the reply. Okay? Well, when you're starting up that program, and you create a chat session object, what you might have to do behind the scenes with the operating system is you might have to set up some communication protocol stuff. You might have to request some networking resources from the operating system. And sometimes, like in Windows terms, you would request a handle to a communication session from the operating system. And behind the scenes in the networking layer, it does all the magic glue so that when you send data over that, it's passed over the network card to the Ethernet, to his network card, and back to the handle of the thing on his side, right? All that magic glue. But in order to prevent memory leaks or handle leaks and all those other things that can happen in sophisticated re-entrant operating systems, you have to be careful about how you manage those resources that the operating system entrusted you with, okay? So, in that case, deleting that object isn't as simple as just reclaiming the memory. You have to call an operating system to function to tell Windows, hey, I'm done with this resource, you can close it. And where's the appropriate place to do that? Well, you can set up some methods of your own to do it, but one of the easiest things to do is say, hey, create a destructor method inside this class. And whenever .NET decides that it's time to reclaim and make that object go away, in my destructor I would say, hey, if that handle is there, if I've got an actual handle, at that point, call Windows and tell it to give that handle back and set the value to null and exit. Now, I've been a good tenant with that resource and I've given it back to Windows when I'm no longer using it. That is kind of the classic place where you would use a destructor in a C# class, is when you've got other resources, file handles, if you're doing a game, maybe you've got a OpenGL graphics port handle, whatever system or library that you're interfacing with, you're holding on to resources as part of an object. Give those back in your destructor. That's the classic reason why you need a destructor. So there's an example of one, but it may be a long time before you ever have to do anything with a destructor, but I want you to recognize it if you see it. Now, destructors are always public. You don't have the same list of access modifiers on these things. It's like, look, if you need a destructor, you know it, and put one in there. You only get one. Do everything that you got to do in the destructor and be done with it. But one of the fun things that you can do is create your customer object or your dog object or whatever your program is. Create a destructor and put a console write line in it and say, goodbye, and then run your program and watch on the screen to see, oh, hey, one of my objects just said goodbye. What was it? And you can kind of get a feel for how often the garbage collector runs. Why did I get a whole bunch of destructor calls right then? Well, the garbage collector must have run and made a pass through and deleted all these objects. And it's kind of interesting if you want to play with it.
I got a question about that. So in other languages that just don't have garbage collectors, like I think Rust is one of them, would you just have to basically shut out every single one of those things yourself before your program will even run?
See, Rust is sort of the next evolution of this class of languages, and they have a lot of high ideals for, you should never need to do any of those things.
If you write good code.
Yeah, because they make you use syntax where it's impossible to leak anything. And it's often very difficult. You often have to be very clever. F#, have you ever heard of that? It's called a declarative language. When you start going to these different paradigms, it can be very challenging for a while to try to figure out, how do I even do what I know I need to do to write this application inside that paradigm? But yeah, Rust has got a lot of things that are meant to be guardrails, like when you go bowling and they put the guardrails up so that you can't throw a gutter ball. That's what Rust is trying to be. Do what you need to do, and I won't let you do anything wrong.
Okay, that makes sense.
Okay, next thing I wanted to learn, transition a little bit into something we call serialization. That is simply a term for, I've got an instance of an object, and I want to persist it in some other form, that I can then turn around and take that persisted form and reconstitute an instance of an object. So that's called serialization and deserialization. There's probably history as to why they use that term and how they came up with it, but it wasn't being used for anything else in programming at the time, and hey, we're using it. So if I've got a C# object, to save that to a disk, like, let's say your file system or a database or something, similar to the way the property evolved over time. So in the old days, you just say, okay, here are my list of variables. Write the first variable, write the second variable, write the third variable. You would just do what you got to do to write the data to a disk, and then you just turn around and do the opposite to load it back from disk. But it's gotten a lot more elegant over the years, so now we can use serialization and deserialization. So the blob of data, I'm being a little abstract and cagey there, because it's really meaningless to our, irrelevant to us which method of dehydrating or hydrating and dehydrating, what the format of the data is. We don't really care, as long as it's reversible. If I write it like this, I can read it and get back to what I had. That's all we care about. And so there was a lot of parsing, so I've had to write a lot of code that parses data. So the first thing, the naive thing that you would do is, let's say my object has an int, a float, and a string. So you'd write the int, 4 bytes. Then you'd write the next int, 4 bytes. You'd write the float, what is that, 6 bytes? Then you'd write the string. Well, how do you write the string? Well, okay, first I'm going to write an int that says how many characters are in the string. And then I'm going to write all the characters of the string. Great, there's my data, save it to a file. Then I'm going to read it, okay? I know how I wrote it, so I'm going to read it the same way. Read the first 4 bytes, that's the first int. Second 4 bytes, second 4 int. Next 6 bytes, that's the float. Oh, here's how many characters. So allocate a string that's this big, and then read all those characters into the string. Great. Then we got hackers. So hackers, they have a lot of fun. They go into the file, and why don't we just, instead of 12 characters, let's make it 4 characters, or let's make it 80 characters. And let's have fun watching the program crash as it set the length of the string to 80, and then try to read 80 characters out of this file that only really has 12 bytes in it, right? Or maybe it was just a bug. Maybe I was off by 1 and I tried to read 13 characters instead of 12 characters, whatever. But you can imagine the scenarios you get into, the problems trying to parse. Not to mention, a few months go by and your boss comes along and says, hey, this object, we also need another int in it. Well, crap, all of our customers have all these files that they've saved that only have 2 ints. And now you're telling me we need another 4 bytes in the file. So now my program reads this file. Well, is it the new file or is it the old file? The new file is going to have 3 ints. The old file only had 2 ints. Which is it? Okay, so I'm going to be clever. I'm going to add another int to my object that's the version number. So I'm going to write the version number of 1 or 2. If I read it back and version number is 1, I know I've only got 2 ints. If I read it and the version says 2, I can anticipate I'm going to have 3 ints. And then a couple of years go by and you keep doing that, modifying, adding, and removing stuff from this object. And now you read this data and it's version number 1 and you're like, how am I supposed to create an instance of this object when all I have is these 2 ints, a float, and a string? Where am I supposed to get their zip code from? What am I supposed to put in there? And it's just, very confusing. So, there's got to be a better way. The good thing about that is it's very compact because it only contains the data that you need. It's only got the minimum number of bytes, and so it seems very efficient. So the next thing came along kind of at the other end of the spectrum. They came up with XML. And XML, if you've seen it, is incredibly wordy. Lots and lots of less thans and greater thans and property names and types and all this stuff. I mean, for that same little file, we may have 1,000 characters on disk just to store those, 30 or so bytes of real data. So it worked. That had its place in history and served us pretty well, supported the versioning, because we could put the version property in there. But then JSON came along, and it's called JavaScript object notation, but that's, I think, historically, that's just because of when it was created. They came up with that format when they decided they wanted to use something like that in their JavaScript applications. And so the two of them kind of went hand in hand like peanut butter and jelly, and so it got called JavaScript object notation. But there's nothing magical about it. It's just a little bit more compact way of representing the data in your object than XML. Okay. This this other thing I'll say about the security by obfuscation, when you're doing this binary stuff, just saving the data out of the file, people would try to tell you that, oh, that's really secure because it's not human readable. You open up it and it's just this blob of binary data and nobody's going to figure out what's in there. Yeah, well, that worked for a while, like I said. But then, somebody coined this term, I don't remember her too, but if you know what machine language, everything's open source. You can read the assembly and figure out what the data is by what it's reading and then what it does downstream with that data. So it's not secure. Yeah, it's more valuable now to just be transparent. Look, like let's say that you had those version 1 to version 2 of the objects, and you wanted to open it up and fix all the version 1 objects so that you could load them as version 2 objects. Are you going to use Notepad? No, because it's all binary data. What am I going to edit it with? I have to have a binary editor, and then I have to be, I'm sitting there modifying the hex, pushing bytes over and inserting new hex characters and all this. It was a pain. But with JSON and XML, you can use Notepad to fix your objects if they got a problem with them. So, and they're human readable relatively, so you can understand what data is in there and fix it if you need to. And by and large, that has been much more valuable in the industry than this whole attempt to be secure by obfuscation that they were clinging to before. So it's much better now. Yeah, so common formats, JSON, XML, SOAP is just XML using a specific convention for all the stuff that we're going to put in it. Microsoft tried to come up with this SOAP format where it wasn't company dependent. The SOAP was kind of out as a separate thing. So if you're reading a SOAP document into a C++ program or a SOAP document into a Java program or something, you didn't care what the language was. It was meant to be kind of language independent, system independent. But it's just a convention for what you put into your XML document, in other words. But very cumbersome, very wordy. Same reason COBOL died. I don't need, a megabyte of source code to do what I can do in 5 lines of code in a Java program. It's more efficient to do it in JSON. And, binary is still useful. So one common way, like right now, if you wanted to use the binary serialization, or where you'll encounter it, is if you have an application where you want to say, Word, Excel, PowerPoint, all these programs that you use every day, they have copy and paste functionality. Well, if you select some text in Word, and let's say the second word of it is bold and the third word is italics, it's got a bunch of metadata behind the scenes, right? If you select that sentence and you hit copy, it binary serializes that data to the clipboard because it's very small. Smallness matters, right? They don't want to use more resources than they need to, and nobody's ever going to look at the data that's on the clipboard. So they just serialize it to binary and throw it out there on the Windows clipboard. So when you go someplace else, you can paste, and it deserializes it from that binary back into the rich text that it started out. Okay, so that's where you'll see binary serialization. But for us mere humans, JavaScript object notation is very practical. Okay, serialization uses, again, what I kind of think of conceptually as an outside-in approach. The inside-out approach, the opposite of that, would be like the toString method, where you call an object's toString method and it returns a string with a textual representation of whatever you wanted to see about that object, right? That's what toString does. But an outside-in approach is more, your main function says, hey, I've got this instance of this customer object. I'm going to call this serializer, and it's going to take that object and pull all the data out of the object and create the JavaScript object notation text. The object never knows or cares that it supports that. There's no function inside the object that says, hey, to JSON, it's not inside the class. It's done outside separately, which is actually really convenient because the JSON serialization library, assembly, all that code is in one place and it works for any plain old object that we call POCOs, plain old C# objects, right? So that's inside out versus outside in. Yeah, so I will show you an example of that. And how does it do that? Has anybody heard of reflection?
Yeah, I was gonna say, how does it even like convert it pretty much? I don't know how it like does it.
So one of the cool things about C#, .NET in general, all the .NET languages, well, and Java has its equivalent, is this concept called reflection. That when you compile code, you can ask it about itself. There are functions in .NET that act on .NET code. So you can say, for example, I've got this class dog. You can write code over here in someplace else that says, hey, here's an instance of a class dog. Give me a list of the constructors that dog supports. And it'll return you a list. And then you can say, okay, I want to call the one that has these parameters, this signature. You can evaluate the signatures of the 3 that come back and figure out which one you want to call. And then there's code that you can use to like abstractly call that and pass it the data you've got as if you were saying new dog. It's really powerful, really cool, and it's one of the things that powers things like serializers, because the serializer doesn't need to know ahead of time what the object is composed of. It can ask the object, hey, give me a list of all your public properties. Then it can enumerate each of those and ask it what the value of that property is, and it can create the document with the little pieces inside it with those values and produce the JSON document.
Is that similar to like a Java doc almost?
Java docs uses that same technique. It uses reflection. So that's the reason why in your Java class or your C# class they have an equivalent. You don't have to put all that stuff in there, like saying the name of the method or the name of the property, because Java docs can just say, hey, tell me the name of the property preceding this comment kind of thing.
And then C# pretty much uses the same thing? Okay.
Yeah.
Nice.
It's really powerful.
Just a question. I'm kind of assuming it was set up in a way that it never really has to be updated, and that's how you don't have to include anything within the C# file itself. It's very standardized and will always...
Yeah, when the definition of the object changes, the way it's serialized changes dynamically. It's very elegant, very cool, very powerful, and it's one of those things that became popular with these modern languages like Java and C#, or Java and the class of .NET languages. Yeah, very cool. Okay, so let me show you the code first. I think that'll make more sense. I have an example. Okay, so I've got this customer object. And I've got some stuff in here that might look kind of like magic, but I'll explain what it is. So it's composed of, see, don't you love that? Now you can use the terminology, right?
Yeah.
This customer object is composed of an int, a couple strings, a float. Yeah, that's it. So that's what it's composed of, is those 4 properties. These are all automatic properties with getters and setters. And then you see this string question mark. So that probably bears explaining. So the difference between a string and an int is an int is a simple type, but a string is a reference to an object of type string that has a length property and then the data of the characters. So it's composed of stuff too, so we have to make it an object. Well, since it's an object, it can be null. So what this says is, it just says, hey, by the way, I'm letting the compiler know that I realize that this name property might be set to a null object. You know, it's not a string of length 0, it's no string at all. Where there's no such thing as no int. There's an int, and it's going to have a value. Whereas string is nullable. So all that says is, yeah, I know that. Don't give me a hard time about it. Where that comes into play is when I have this constructor, any nullable type that this object is composed of, I kind of need to initialize it in here. To protect myself, like the Rust thing, protect myself from some time when somebody's going to reference this variable, this instance of this, or this data member that's part of this object. Maybe nobody initialized it yet, so I'm going to get a null reference exception when I run this line of code, and C# doesn't want to let me do that. But if I say, oh, by the way, that could be null, then it says, okay, you're aware of it, you'll take care of it. Yeah. So, there isn't anything in here other than the namespace, which has nothing to do with the code. There's nothing in here that says anything about JSON. I mean, I've got this. I think this is just leftover. I don't think I need this. Yeah, this is probably can be removed, so ignore that for now. That's just my screw up. But the point is, there's nothing in here that tells this object that it's capable of or that it needs to do anything different in order to serialize this object as JSON format. It's completely unaware. Okay? So I go over to the main function, and this is how I would do it. This is no big deal. I create a new instance of a customer. I'm going to set the ID, the name, and the credit limit. Question, what the heck is this syntax? Huh? Another little rabbit trail. I mention it this way because the book points this out. I think it's kind of a non sequitur. They could have skipped this altogether. This syntax came along in C# when they invented anonymous methods. This is not some new kind of constructor. So don't be confused that, oh, that's just calling a constructor that takes an ID name and a credit. No, it's different. If I wanted that, I would have created a customer where I pass right? I didn't create a constructor like that, so I can't call one. But C# created the syntax that lets me say, okay, I want to create a customer, and by the way, I also want to initialize it like this. So it's calling the default constructor, and in this case, it's not the default constructor because I gave it a constructor that takes no parameters. But it's calling that constructor still, and then afterwards, after it returns the new instance of the uninitialized object, then it calls additional methods. It says set the ID. This is no different than if I had said that's what this is doing. It's not doing anything constructor related. It's just a handy syntax for saying, this looks kind of elegant. It looks like I'm creating the object and initializing it all in one step. But it's doing nothing different than this. Make sense?
Yeah.
So, but now you've seen that syntax, so it won't freak you out if you see it in the book. Okay? All right. End of the non sequitur. So, I've created a customer object, I've initialized it with these values. Now, I'm going to create a string, and I'm going to use this JSON serializer object See, I just said using system.text.json up here, that's where that comes from, is that library. So I'm going to call the method. I might also point out, now that you know what one is, this is a static method. I don't need the instance of any object to call serialize, because I'm passing it everything that it needs to know. I'm passing it a customer object, and it's going to use reflection to interrogate that object, get all the data out of it, and produce a string in JSON format. Pretty simple, right? It's an outside-in approach. Customer doesn't know anything about it, but this function knows how to interrogate it and get what it needs. And then this other line here, that's just some options. By default, if I serialize this to JSON, all of the field names that it inserts into that JSON document are going to use Pascal casing, capitalizing the first letter of every word. And I said, I want to do something a little fancier. I want to use camel casing. I want the first character to be lowercase, and then each word to be uppercase after that. So, no big deal. And then I'm going to print that to the screen. That's all. So this right here takes, you can replace customer with any plain old C# object you've got, and it will serialize all the public data about that object into a string. Pretty cool, huh? And you can do with that string whatever you want to. Now deserializing is a little different, because I've got a string, but how do I know that this is a customer object string versus a dog object string versus a tail object string? Don't. So I need to give it a clue. And this syntax is using generics. We may learn about that later. But there's a method of deserialize, called deserialize, that is parameterized. It needs to know, I want you to act as if what you're getting is a customer object. And it will take this string, reconstitute a new customer object, set all the properties to what it gets out of the string, and it returns a var, right? What do you think the type of this dehydrated object variable is? Right? I didn't say what the type is up front, I said var, but what is the type of that dehydrated object variable going to be?
Maybe a string?
Yeah. Serialized customer is a string.
Oh.
What am I going to get back from deserialize? What do I want back?
The object that it is?
An object of type customer, yeah. And that's the glue here. When I use this syntax, putting the type inside these less than greater than, that tells deserialize, oh, by the way, the object that you create, I want you to typecast it as a customer. And that tells it, deserialize has to use reflection too. But it says, oh, assume that what you're getting is going to apply to a customer object. So when you get that property, put it here. When you get that property, put it here. When you get that and then return something cast as a customer. So yeah, dehydrated object is going to be of type customer. And so then what's this doing? When I say right line a customer object, it's casting this as a string, so it's going to come back here to the definition of the customer object, and it's going to call it toString. Like I said, the old days, I could have used my toString to serialize it, and then I could have said, well, I assume that the string that I created is going to be in this format, so I will parse character by character each. And then JSON deserialize does all that for me. I don't have to do that. And when I write the code myself, it only applies to the customer object. But when the deserialize object does it, it applies to any possible object that's made up of plain old C# objects.
Does that, so you put that camel case thing in there for when you serialized it, does it not affect when you're deserializing it? You don't have to specify anything because of that?
Correct. I believe that's true. It worked, so I think that's confirmation that it's true. Yes. So it must just not care about the case. Which begs the question, what if I had two different properties, and one was uppercase and one was lowercase? How would it know when it deserialized which to put it in if it's doing it case sensitive? I don't know, maybe there's weird edge cases like that. But you can also do stuff, and then going back to the PowerPoint, you can also do stuff, now this is breaking that rule of, well, now my class knows that I might JSON serialize it, because I could put this attribute on one of the variables and say JSON ignore. And what that tells the JSON serializer is when you're saving this object to JSON, don't, skip this property, don't include it in JSON.
Why would you want to do that?
Like in this case, like credit limit, maybe it's sensitive data. Like if you had an account object and you didn't want to serialize the password. Any number of things I can think of why you would want to do it. Or calculated fields. Maybe if you have a circle object and it has an area property, well, I calculate that, so I don't want to serialize it. Yeah, so I missed something here because this is supposed to be the example of how to do, I think this was a copy-paste issue. I didn't copy it right from my source code to paste it in here, but there's a way that you can change it, like instead of credit limit, you can say, no, I want you to use a different name. Maybe I just want to use the word credit as the name of the property. You can do that. There's all kinds of stuff that you can do with these attributes to customize and tweak how it gets serialized and deserialized. Yeah, and then the naming convention, we saw the example of that. And that's pretty much the end of what I wanted to go through tonight. Thank you for bearing with me. I know that was kind of long, pretty densely packed with information, but hopefully going along with that and reading the chapter 9, now you'll get the context. The book is great, but it's more, like I said, more encyclopedic in how it goes through all of these concepts, but sometimes the context that they give you around them, I would have said it like this, so hopefully getting both of them will give you the full picture and hear it two different ways, and we'll fill in all the blanks that the other missed. Any questions?